Righto, Year 12s, we're back. I'm sorry about the lateness of all of this stuff. My battery went flat and I lost all the videos. Right, so we're starting again. Now, we have looked at a video, hopefully. We have seen already a question about finding the area between a curve and the x-axis, where I've got areas above and below, but I want to talk about the absolute value of all of those areas, right? I want to treat them all as magnitudes. So we work them out in separate parts and add them together. Second question here that I want to look at is the area not between a curve and the x-axis, but the y-axis. So listen carefully. What we do here is sketch the curve. We re-evaluate the bounds of our integral for the new axis, for the y-axis. I rewrite my function with x as the subject. So I want x equals something with something, a lot of y, and integrate it with respect to y. Okay, I'll show you how that works. Now, fortunately, we've got a nice, easy function here. Right, so x and y, x plus 1. It looks something like this. There's -1, there's 1. Okay, and y equals 5. Looks like this. So this point here is going to be 4, 5. This point here is going to be 5. And I, of course, am interested in this region in here. That's my region there. Okay, I've got a triangle. That's the area I'm trying to find. Of course, now this word here, well, that's a fancy word. Mensuration means like measurement, right? We could, of course, work that out. I know that's 4 and then that's 4. So it's going to be 8 units. Right, I can work that out. That's part C done. Yeah. But we're going to integrate with respect to y. Right? Not because it's going to be the easiest way, because I've already showed you the easiest way is to work that out as a triangle. But let's integrate this with respect to y. So what did I say? I need to sketch it. Done. I need the new bounds. So we are going to go from 1 to 5 on the y-axis. They're my bounds. Not my bounds here, which would be from 0 to 4. From 1 to 5 on the y-axis. And I need to write this. If y equals x plus 1, well, subtracting 1 from both sides would tell me that x equals y minus 1. Okay. Therefore, we want to calculate the integral, the definite integral, from 1 to 5 of y minus 1 to y. And that's equal to half y squared minus y between 1 and 5, and that is equal to, I think it's 15 over 2, 15 over 2 minus negative half equals 16 over 2 equals 8. Right, certainly that is a long way around to answer that sort of question, but it's an introductory sort of thing to see that it works. Okay, to see that it works. It's easier to do that than chuck a parabola in there or something, because rewriting that equation is going to be hard. Okay, so we can do that. That's part B done. Use integration, right? It says use integration. So that means that you can't answer that question. You're not answering the question as asked if you evaluate that some other way with respect to y, okay? Do I mean with respect to y. Righto, confirm the result by mensuration. Okay, for part C, area equals half the base times the height equals 8. We'd look at 8. Anyway, that's how we do these. I'm sorry for how late this stuff is. If you don't get to watch it tonight, hopefully you get to watch it sometime during the lesson. Okay, thanks very much, 12s. Jot down questions for me. Ask me questions in class. I would love to answer them. I'll see you then.